Okay, here is question number 5. A researcher studies the water clarity at the same location in the lake on the same dates during the course of year and repeats the measurement same dates 5 years later. So what they are doing at a lake, they are trying to check the clarity of the water. The researcher immerses a weighted disc painted black and white and measures the depth in inches, which it is no longer visible. So basically, they are seeing how clear the water is. So it is more clear if it is at visible at more depth, right? So here is the information. Observation first, second, third, and fourth are at these dates. And first year it is 60.2, and then 5 years later it is 66.3, and so and so. Okay, let's read the question. Why is it important to take the measurements on the same date? Read the options. So basically, they are trying to pair the data, right? That is what is happening here. Using the same date makes the second sample dependent on the first. So we are relating and compare between the same times of the year. That should be the reason, but I just want to show what are the other possibilities. Using the same date maximize the difference in the water clarity. No, it doesn't affect that. Using the same dates make it easier to remember. That shouldn't be the reason. It's not about convenience. Those are the same dates that our biologists use to take water. That's also not the correct answer. Okay. Does the evidence suggest that the clarity of the lake is improving, right? So what does that mean? In first year and then after 5 years, if we are calculating the difference, if the depth is increasing, that means we want to check that mean in the first year, mean 1 is has to be less and mean 2 has to be more. Because why are we saying that? Because the more depth, that means it's more clear. The clarity of the lake is improved. That means mean depth after 5 years is more. So that means mean first. So that means the difference is negative. That is what we need to test here. So H naught is about the difference. H naught is always equal to type no matter what. And we are checking it is 0, equal to 0. What we are testing is that the difference is less than 0, because we want to test that the depth has increased. So mu1 is less than mu2. Let's check that. That was our hypothesis. Now determine the test statistics. So one way would be in your calculator, in edit, you enter your stat edit the first x1's list, and in stat L2 you enter the second list. So let's do that. So you see how I entered the list. Now to calculate test statistic for the differences, because this is pair data, we need to use t-test, but first we need to find the differences. How you do that in calculator? You go to this top L3 thing, and then you type here L1 minus L2. Second one will type L1 minus second L2. Enter. So you see here the differences column come. Now to find test statistic, you need to run test stat test t-test. But now you need to use data, which is because we have the data in here. Mu naught is 0 because this value here is 0. And list is in L3. If you just check, we found the differences in L3. That's correct. And our alternate hypothesis is less than type, so you need to highlight less than and then go down to calculate here. So t value here is your test statistic. You're gonna write minus 3.67, rounded to 2 digits, and the p value is 0.007 for the 3 places. Okay. Now, what is happening is p-value is very small. Let's compare it to alpha. Alpha is 0.05. P-value is less than alpha. That means reject H naught. So either A or B. So if you reject alpha, H naught, then you are accepting H1. So there is sufficient evidence. Reject H naught, then there is sufficient evidence to at this level to conclude that the lake is improving. Check that. Draw a box plot of different data, right? Now, if you see our stat uh, list, if you check, our difference data is into L3. So if you want to find the box plot for difference data, you need to draw the box plot of L3. So second stat plot, check that, and you need to highlight the box plot with the outliers, this one. And in the X list, it should be L3. If in your calculator it's not L3, you can just press second and 3, it will become L3. If it is like L1 or L2, you make it L3 by pressing second 3. And then this is it. And now we press zoom 9. This is your box plot. To check the values, you can trace the median is at negative 4.35. So check which one of these three medians is at negative 4.35. This median seems to be like near 5. This median is not at. And what is the lowest value? Is negative 6.4. So I think this one is looking like it. But I want to check the rightmost value is zero point 0.1. So this is more than 1, not this. Um, this is also not the correct option because the rightmost value is zero point 0.1. So I think it's C. Okay. Does the visual evidence support the results obtained in the part B? What did we say in part B? We said there is sufficient evidence to conclude that clarity is improving. That means that there is sufficient evidence, what we are trying to say, that the evidence shows that mu1 is less than mu2. If mu1 is less than mu2, then mu1 minus mu2 will be less than 0. And you see our box plot is also showing that the differences are mostly negative, right? It's only a one small bit is going towards the positive side. So does the box plot also, does the visual evidence support? It does, right? So yes, because the box plot, the lake is more clear since most the differences are negative. Most of the differences are on the negative side. That is what is representing that mu1 minus mu2 is less than 0. Okay, this is it for question number 5. I hope that helps.